Ali is the.
Am I the chair of this session? I don't know. You're the chair of this session.
You want to share?
No.
No.
You go.
All right. I think we should start, right? Hello, everyone. Well, thank you for joining this demo session. We're going to start with Monos's specialized polyphonic granular project.
Hi for me. I'm Manos Dimogradakis. I'm a student in Aalborg University, and today I will present digital musical instruments that I built it in Max MSP, but actually I'm still building it, so it's a demo. So I'm using granular synthesizers. And I wanted to have control of the grains into the space. So I wanted to have like a real-time manipulation of clouds of grains, like to control the density and the position of these clouds. I found that, and it's super intuitive, to control something in a space with trackpads, if you want to say that. And yeah, and I'm using two trackpads. One of these, it's the Sensel Morph that you can have position and pressure sensitivity. And for the granular parameters, I'm using just a simple trackpad that I'm having faders like as graphic tables. Okay, so Sensel Morph, the one that you saw that I had in the left, right, it's a trackpad that you can, as I said before, pressure sensitivity, so you can think of it as a, let's say, as a map of a space. So you could have an intuitive idea of where the sound objects that you want to control are. So here I mapped some groups of grains into the fingers, and for this application I have five group of grains, and these groups have like 5 grains. So by applying pressure to the Sensel Morph, you could have I mapped here because I'm using binaural in this system, so you could have a levitation. And yes, I'm using SPAT5, as you can see. It's a super nice tool, and you could have a lot of different formats for specialization, and yeah. Okay, and here you can see actually the parameters of the granular synthesizer that I'm using. It's just like simple, just the simple basic parameters that you can find in a granular synthesizer. Here, instead of pitch, all the other parameters are in milliseconds, and the pitch is just, you can see, a multiplier. And I can show you a video if you want. Another thing is that in this application I'm using a pen, but I want to find something else. You can change these parameters with a pen. I don't know. I can show you a video if you want, but it's in binaural format, and I don't know if it is acceptable. I don't know. Sorry, Stefani, about that, but. Let me move it a bit. Okay, here you can see, let me let's stop it. It's this. Tell me. What? Sorry, yeah. You can see two different representations. You can see the YX space here, and there you can see X and Z, like it's the levitation axis. Okay, and just I will show you some stuff. How is it? So you have an idea, and please come and take it if you want and play with it. Thank you a lot.
Thank you. Next, we have social musical gaming with Count Me In, Juan Pablo Crescel.
Hello again. It's me again. Hi. This presentation is actually not going to be a presentation. I would like you to just take a look at this. So this might go horribly wrong, so I apologize in advance, but maybe it works. I would like to invite everybody to scan that QR code. I hope we can make it bigger somehow. It's going to ask you to enter your initials. It's going to be very chaotic, but hopefully it's going to be fun. And 10 people are going to have access at any point in time. Later they will be kicked off, and then all of you can try it out at some point, hopefully. Here we go. Oh, no. Something going wrong, as usual. One second. Don't worry. Let's give it another try, please. Whoa, that was fast. Okay, it's not working. So I hope you visit the poster later on to show you how it works. Thank you.
Thank you. Next, Astrid Peterson is going to present Playing the Virtual Glass Harmonica.
All right. How was this? All right. Hello, everybody. I'm Astrid Peterson, and I'm from Aalborg University. And I'm here presenting my bachelor thesis on behalf of my bachelor group. And as you can see here, our goal was to create a virtual replica of the glass harmonica. And a quick history lesson for those who are unfamiliar with the instrument. It looks somewhat like this. And it was invented by Benjamin Franklin after he was inspired by the musical glasses, which is like when you rub a wine glass to produce sound. The instrument was extremely popular in its time. But curiously, today, it just resides as a museum piece. And this whole project was done in collaboration with the Danish Music Museum. As VR is becoming increasingly accessible, more institutions, such as museums, are including these interactive technologies in order to make their museum feel more alive. And this was the initial inspiration for this project, as we wanted to make use of VR's ability to make the instruments transgress the normal limitations and come into the hands of the visitors. So this way, our goal was to enable the gesture interaction and the sound quality of old forgotten instruments, and in this case, the glass harmonica. So when you're designing such an interface or for a virtual reality musical instrument, the first question pops up is, what about the playability? And to be more specific, how do we increase such playability of our interface? And this is where our haptics come in. The musical haptics, or the very intimate relationship between the haptic and the auditory feedback, it has been extensively studied. And also the physical coupling between an instrumentalist and an acoustic instrument is also almost unavoidable. So in the context of this musical instrument, the glass harmonica, when you're playing it, it again is much like a wine glass. So if you put too much force on it, it's not going to actuate any sound. It's not going to resonate. So the physical coupling between us as a player and the instrument is also key to this. So with this in mind, we wanted to find out what device would be appropriate. And we were lucky to have the opportunity to work with this VR touch diver, which is a variable haptic device which renders force, vibrotactile, and thermal feedback in the fingertips. And it was very appropriate for our project, again, as force is such an important feeling when you're playing this, when you're playing the glass harmonica. So yes, this is our device of choice. And the way that we rendered or calculated the force value was through considering the displacement of the virtual hand colliding with the virtual glass balls, and then the location of the real hand. And then the calculated force value was then used as an input into the actuators and also mapped onto our bow pressure parameters of our physical model, which we acquired from Faust toolkit. So these are all very pretty words, but we also obviously need to evaluate this. And we did so through a task-based evaluation where we asked the participant to play the first part of Elise. And during the performance, we measured the time that the user spent within the correct amount of force, and also the amount of times that they exceeded the max force. And through a statistical analysis, we saw that there was a significant difference between for both matrices in favor of our experimental condition or our haptic condition. And also through our qualitative data collected through our interviews, we also saw that not only did it increase the playability of the interface, but it also increased the general experience. So don't just take my words for it. You should come and try it yourself, and you should help us resurrect the glass harmonica. And thank you.
Thank you. Next demo is AIM Package, a modular standard for structuring patches in Max by Vincent Godard.
Hi everyone, I'm Vincent Goudard, and I will be presenting a Max package called AIM, which is actually part of a much larger project ongoing project at Volvo Cars Company. Oh, they should be okay. I should put that full screen maybe. So that's why there is this little logo there, down there. Okay, how do I put full screen? Whoops, I just broke the computer. Okay, that's shifted presentation. Okay, never mind. You will see the poster that's an exact copy, so you will see that there. So the project itself is aiming at designing a complete audio experience in a car. So it involves many other aspects like hardware development and custom algorithms. So what I'm presenting is actually only a small subset of the software development, and one of the challenges is that many people with different area of expertise are collaborating on this project, ranging from people concerned with hardware aspects up to sound design and composition. So the goal of this package is also for the people to be able to collaborate at various levels of the development. The AIM package Yeah, that would be cool to have the poster. Never mind. The AIM package is a framework for designing higher level components in Max. And so who knows, little poll, who know the Jamoma package in Max? No one? So I'm getting very old now. I feel very old. Well, we are getting old. Okay, so that's why the tagline is a modular standard for structuring patches in Max. Well, the goal is not so much to go toward a standard, but I actually borrowed it from the article by Tim Place and Trond Lossius, who back in 2006 developed the Jamoma project. And the goals are very similar. I was very much inspired by this project, and also its latest implementation, which is Libosia, which you may hear about tomorrow by the presentation by Pia Balthazar. And the goal is to be able to create models. Okay, so I should move around. I should navigate in my poster. Yep. So basically, yeah, you can define models and parameters and bind parameters to models or submodels to models, and so you can organize your hectically patched max patch towards more reusable components. And the benefit of it is, for example, that you can save and recall preset at any level. So for instance, if you created a model for, say, if you created a model for, say, a simple biquad filter and create presets for that, and then you will build a more elaborate multi-channel, multi-cascaded filters, you will be able to get all your presets for the biquad in the multi-channel equalizer. So that way you can reuse presets and model at any position in the patch. And if you have many instances of a biquad, same, you create a preset here and it will be available at that other place. And also it provides way to more conveniently address parameters with OSC friendly and wildcards and brace notation expansion, all kind of facilities to be able to access when you have zillions of parameters, or almost. It's sometimes useful to have a convenient way to address any of those parameters or groups of parameters. So this is part of what this package is taking care of. And if you want to know more about it, then come have a chat at the poster. Thank you.
Thank you. Next, we have a virtual reality volumetric music video featuring New Pagans by Garrett Young, Neil Doyer, and Eljosa Smolik. We have, yeah? I guess we're gonna go to the next one. So the next demo is Music CI Call, Adventures Virtual Reality as a Musical Training Program, and Stina is gonna present it.
Okay, so I'm Emil, and this is Sine, and we're from the Multisensory Experience Lab at Aalborg University. And we are here presenting our bachelor project, which is a musical training program for individuals with cochlear implants. And we made this as a virtual reality application. So First off, what is cochlear implants? Just a short introduction. Cochlear implants are devices bypassing a damaged ear for people who are with severe to complete hearing loss, and actually stimulating the auditory nerve directly. So in comparison, a normal hearing aid amplifies the sound directly into the ear. So the cochlear implant actually bypasses a damaged ear, making possible for deaf people to hear sound again. The problem is that the sound is very different from a normal hearing, and is often described as very metallic and tinny. And people are able to regain most of their speech recognition. However, music is something different, and a lot of CI users actually give up on listening to music completely, and they rate their enjoyment of music much lower than normal hearing people. So what we are focusing on are the limitations of the device, such as the pitch perception and the perception of timbre, so the ability to differentiate different musical instruments, and not completely in the context of music, but also the direction of sound, which of course is dependent on whether you have one or two cochlear implants, whether you're unilateral or bilateral. So, yes.
Yes. And there have been previous musical training programs for CI users where some aspects they've been training before is instrument identification, melody recognition, and sound localization. So what we did is made a virtual reality training program with these 3 levels and 3 difficulty levels. And by using gamification, we made them able to, gamification feedback elements, they were able to track their progress and their possible improvements during gameplay. And we've been testing this on one CI user. He was actually a musician prior to losing his hearing 27 years ago. And he had the prototype for 1 week and did a diary study. And afterwards, we had a post-test interview where he mentioned, the pros and cons, of course, of the prototype, but some results, especially in melody recognition and spatial awareness, he actually was motivated to keep on training in this program and see if he was able to regain some of the listening capabilities that he had actually given up on since getting his CIs. And this is why spatial sound might be appropriate in virtual reality, to see if it's more immersive and more engaging to feel as if you're present in an environment, whereas previous musical training programs have mainly been web-based or mobile applications. And we wanted to see, if we were to continue development, if people have an easier time translating their training to real life, if they feel present in the environment. And this also shows other potentials. For example, it could train the cocktail party effect or concerts. And again, virtual reality did show some potential for trying to mimic what they would be like if they were to use these capabilities in real life. Yes. And of course, this framework for making the MTP it's possible to translate it into a mobile application as well, to see if, just to decrease the possibility of limiting the target group, since virtual reality is not for everybody. But it should definitely be explored further, and seeing whether virtual reality is actually an improvement for immersing and entertaining people while improving their capabilities with music. Thank you.
All right, next demo is titled Somax 2, a reactive multi-agent environment for co-improvisation by Joachim Borg, Michael Malt, and Gerard Say.
Oh, thank you. I will try. Let's see. Not this one. Oops, sorry. This one. I am supposed to be here. Oops. Can I close this? Just closing this one. Oh, just oops. Oh, oh, sorry. Bad. Oh, it's here. And it's the 4th one. I hope so. Okay. Oops. Okay, hello everyone. I hope and imagine from everywhere. I am Michael Malt from the Représentation Musicale team from IRCAM. And I am going to make a demo session on Somax 2, a reactive multi-agent environment for co-improvisation. But just to give a little bit of context, the Somax project is a part of an A&R project, Merci, Mixed Music Reality with Creative Instruments, and the ERC project, Reach, Raising Co-Creativity in Cyber-Human Musicianship, where the PI, Principal Investigator, is Gérard Assayag. Unfortunately, you can't see it very well, but I can give you after the link. All the project, it's free and is on GitHub. You can download and use at your expenses. And anyway, just another point, very important, the actual version is developed by Joachim Borg under the supervision of Gérard Assayag. And the actual Somax 2, it's in fact a recent development and algorithm improvements from the former Somax version that especially by Laurent Bonas. And maybe you ask, okay, by Michael, who you are. I am just a part of the Crash Artistic Pilot Text crew that are using Somax 2, and I hope that you could follow the performance on Tuesday, okay, where I was with my colleague Simone Conforti with an EWI, electronic wind instrument, and Benny Slushin with acoustic trombone. I could not put the video capture credits. Sorry, maybe this is very important because the video capture was amazing good, really. Very good light, very good composition. And if you can put it on the link, you'll be very, very nice. Okay, just to continue. The Somax 2 that I am going to make a small demo, in fact, comes from a long lineage of computer-aided improvisation paradigms and environments that was developed by the Représentation Musicale team at IRCAM. In fact, these environments work, if you want, on the triptych listen, learn, and generate. And this triptych and this Somax co-improvisation paradigm has been refined and give some co-creative softwares. You have Improtech, DIC2, and Somax that I am going to present to you. Actually, Somax, I know that I am speaking a lot. I am going to give some examples in some minutes. Somax 2, it's a reactive co-improvisation environment that can learn from MIDI files, audio files, and also have the concept of autonomous agents. That means autonomous agents that can interact one with the other, listening with one the other. Okay, just in a nutshell, how it works. The first phase of working with Somax is an offline phase. It's a learning phase where you are feeding the environment with MIDI files or audio files. These MIDI files and audio files are going to be segmented, and each segment analyzed from the point of view of pitch, chroma vectors, and amplitude. And from this we have a corpus. Our corpus is going to be what we will call a navigation model. It's in fact our corpus. It's going to be a set of files containing n-gram models of each parameter layer. Okay. After we do it, in Somax we have these agents that can generate musical material, can be symbolic audio, MIDI, or even audio. And what is very nice, the players, 1 minute, okay, I am in time, it's good. That means that the players can listen one to the other, but also they can listen external influencer, MIDI instrument or audio instruments. Just the last really aspect, very important aspect, that all the matching process doesn't not only take in account the actual match, but has a memory of the past matches, like in Markov models. Okay, last point about the implementation. The implementation, we have a front end that is with Max, and we have a back end that is a Python server. Okay. It's done, and see you if you would like to speak about the model, the software, the use of generative models in musical performance, about aesthetic issues and formal models, and how we say in French, et plus si affinité. Thank you.
Thank you. Our last demo is titled as PD on an IoT class processor by Miller Puckett and Kerry Hagen.
I'm sorry for the mask. Actually, I'm the last person to use the microphone, right? Okay, do that then. So what I want to do is start with the demo, because it was working 15 minutes ago, and so there's a 50% chance that I can get it to work right now. And then you don't have to come see my booth. Okay, so what I gotta get this thing. Enjoy the demo while I figure this out. There's some other text on the, oh yeah. So first off, here's what's going on. This is one of the examples from the PD distribution that some of you have probably struggled through, so thank you for dealing with that. And what is going on, the interesting thing is this part, which is the battery it's running on. This should be going for a couple of hours. That's a 500 milliamp hour battery. And what's going on is that it turns out that you can run pure data on a processor that has a 0.5 megabyte of RAM, which is 1/1000th of the smallest amount of RAM in any of your computers or phones, right? Why that's true is because PD is written in an extremely compact way. The overhead for an object is 44 bytes and things like that, right? So what we're doing is we're running PD not in Linux, but in free RTOS, which gives you system calls that are Unix-like, but is a real-time operating system, and you get various things. This particular card is called the Lyra T Mini from Espressif, and it costs $22. That's part of the thing that's off the bottom, and you get all the things that we need to do this project that we did this for, which is specifically a bunch of like 20 whispering pillows. So the point to this was to make a series of 20 pillows that whisper, that we could leave in couches and chairs in some kind of pre-function space to bother people, right? And so the idea is it has to run all day on a small battery. It has to be small enough and light enough to fit in a pillow without being noticed, and it has to make some sound, and it has to be networkable. So Bluetooth is the networking. The other thing I should say is there is a file system that, the SDHC card that you can plug in can have gigabytes of stuff, right? But the patch, we actually download over Bluetooth because it's easier the patches are just messages, right? So you just send messages to PD over Bluetooth to create the patch, and that way you don't have to worry so much about stuff. And what else do I have to say? This is, how much time do I have left? Probably not a lot. Okay, so I'll see if I can actually scroll. There we go. My cheat sheet. These are the talking points. The most important thing is this whole thing runs, including the speaker, on a watt, which is a lot less than your phones probably dissipate. And we use one of the two processors in the Espressif, which is running at about 1/10 of the speed of your phone, right? And that turns out to be enough to run a patch with hundreds of unit generators in it. So you can do everything that you could do on the ISPW, including all of the IRCOM repertory from the 1980s on one of the two processors on this thing. So it's a lot of trouble to make this and to make it work, but it's actually worth it, and I haven't put it up on GitHub yet, but what I'm going to do is show what you had to do to PD to get it to run without an operating system, which involved a little bit of surgery, throwing out some of the files in PD and then putting in a little 800-line stub in the place of the editor, which does not exist. And then you've got PD running inside your pillow. And that's my demo. Oh, and the real demo then was going to be me trying to set up the Raspberry Pi in this and make them talk, which will take an hour.
Thank you. That was all the demos. So feel free to actually visit the sessions.